Good morning. This morning we're going to look at study guide for 3.2.1. It's slope-intercept form. We've seen this before, so I'm hoping that this will feel familiar to you. Main idea, writing a linear function in the form y equals mx plus b. Fill in the blanks. A linear function is any function whose graph is a straight line. Remember, it's got to pass the vertical line test also. So this straight line here, it could pass the vertical line test. If a line got too curvy, it might not pass the vertical line test. The graph of any non-vertical line can be represented by the equation in the form y equals mx plus b. So list 3 steps you should follow to write an equation in the form y equals mx plus b. So they are, apex is looking for compare the change in y over the change in x. So we know that change in y over change in x is the same thing as slope. We've already talked about that in class quite a bit. There's a starting value for the graph, right? Starting value is same as the y-intercept. So what does that look like? The starting value looks like this spot right here if the graph goes like that. And that's the y-intercept. The y-intercept is the same thing as the starting value, and then the change in y over the change in x is the same thing as the rise over the run. It's the slope. And the third thing that you can do to write an equation in the form y equals mx plus b is to find an equation for the line. So you can find the equation by finding the y-intercept and then finding the slope, putting the y-intercept in for the variable b and putting the slope in for the variable m, and then you've got your equation for that line. All right. My heater turned on. I hope you can still hear me. So the equation that represents Susan's customer service call is shown below. So Susan's customer service is right here. So to get help for a computer problem, Susan pays $5 to be connected to the customer service, and then it goes up. So it goes from 5 to 8, and then 8 to 11, 11 to 14. So we have our initial cost right here. So just even to make the phone call, she has to pay $5. So that is going to be the initial cost. And then on the graph here, we saw that it was going up $3 each, right? For each minute. So $5 just to get started with the phone call, and then $3 each time, each minute. So that we've got to come back here. And that tells us that $3 is the cost per minute. And this is also known as the slope. And its initial cost is the same thing as the y-intercept. So the y value is the total cost. Oh, right. So we have our slope of 3, our y-intercept of 5, and the total cost. And this means something. So it costs $5 just to start that phone call. Hey, I've got a problem with my computer. Do you agree to pay $5 to continue this phone call? Yes, I do. And then I'm telling you about my computer problem, and it's $3 every minute. So this can actually mean something. It's too bad I didn't spell that correctly. There we go. Next page. So compare this equation, y equals mx plus b. The slope, or m, in y equals 3x plus 5 is 3. Because remember, slope is m. So the slope is 3. And the starting value, or b, is 5. Starting value is the same thing as the y-intercept. Name two characteristics of non-vertical lines that make slope-intercept form a good choice when writing an equation for this type of line. So there is a constant rate and a starting value. So again, the constant rate is known as the slope, and the starting value is the y-intercept. Using slope-intercept form to graph a linear function, the graph of the function y equals 2x plus 1 is a non-vertical line. This is a vertical line. So this is a non-vertical line because it has value for slope. Remember, this would be like 2 over 0, and that's undefined. A vertical line is undefined because there is no x movement. Remember, slope is rise over run, or y over x. So this vertical line has no movement to the right or the left, so there's 0 for x. So a vertical line is undefined. So now we're going to follow the steps in the table to graph a new linear function y equals 2x plus 3. So determine some points on the line. All you have to do is choose a value for x and then substitute that value into the equation, into the function. So when x equals 0, 2 times 0 is 0, plus 3 is 3. When x equals 2, 2 times 2 is 4, plus 3 is 7. So substitute 2 times 3 plus 3. 2 times 3 is 6, plus 3 is 9. Then substitute 4 for x. 2 times 4 plus 3. 8 plus 3 is 11. Now plot those points on this graph. 0, 3. So 0 for x, 1, 2, 3. And then 2 for x, 7 for y. 1, 2, 5, 6, 7. There's 2, 7. 3, 9. 3x. And then 8, 9. There's 3, 9. And 4, 11. So 4, 10, 11. And if we've done our work correctly, they should all lie on a straight line, which they do. Okay? And calculate the slope of the line. This is something that we already know. We already know the slope is 2, but let's go back to something that we've worked on already and show how familiar it is. At least I'm hoping that it's familiar. So using this equation, this formula, y2 minus y1, let's use these values here. So 11 is my y2, and 9 is my y1. When y equals 11, x equals 4. 4, and then when y equals 9, x equals 3. So that's going to be 2 over 1, or the slope is 2. And that's the same information as we had in our initial equation, in our initial function. All right. Which statement correctly describes y-intercept? Circle all that apply. The y-intercept of a function is the point where the line intersects the y-axis. Let's check. This is the y-intercept. It's the place where the graph intersects the y-axis. And that's 3, and that is the number that they gave us right here, 3. So yeah, that's true. All right, let's check that next one. The y-intercept of a function is the point at which x equals 0. So let's check our graph right here. The graph crosses the y-axis, and what is the x value? So x is 5, 4, 3, 2, 1, 0. So right here, x equals 0. Is the graph crossing the y-axis when x equals 0? It is. So that's true. The y value of the y-intercept is the same as the starting value b. Let's check. So in this equation, our starting value is 3. So when x equals 0, y equals 3. And is that the same thing as this point right here? It is. This is 0, 3. So the y-intercept is the same thing as the starting value. So look again at your graph for question 5. What is the y-intercept? 0, 3. So it is the point 0 for x, 3 for y. In your own words, explain why you think y equals mx plus b is called slope-intercept form. Okay. It has the slope m, and it has y-intercept b. So I think that's why it's called slope-intercept form, because it has a slope and a y-intercept. Identifying functions as linear or nonlinear. A linear function looks like a curve or a non-vertical line on a graph. A linear function, we just did one that looks a little bit like this. So a linear function is a non-vertical line. Remember, if it's vertical, then it is undefined because it has 0 x value, 0 run. So this one is undefined, so it has to be something that's not vertical. So can it be written in the form y equals mx plus b? This one could. It was plus 3, 0, 3, and it was 2. So yes, it can be written in the form y equals mx plus b. A nonlinear function looks like a curve on a graph because it's not a line, all right? It cannot be written in the form y equals mx plus b. So just do a quick check for number 10 here. Circle the equation that is a linear function. Does this one have a slope for m? And does it have a y-intercept? No. Does this one have a slope? Yeah, it's got a 4 there. It's got the x variable. It's got a y-intercept. So yes, this equation is a linear function. This one is not. It has an exponent. So that one's not going to be a linear function. And this one also has an exponent, so it's not going to be a linear function. Nope and nope. Excuse me while I turn my page and grab a drink. Given a table of values, you can graph a function. Complete the table to identify the points you should plot to graph the linear function. So negative 3 for x, negative 3 for y. You're just putting in the same, just put those points on a graph, and then you'll see that it's a linear function. So 0, negative 2, 3, 7, and 6, 16. So fill in the blanks to show how you can identify a nonlinear function from an equation. So not a line, remember? So you need to generate some y values for several x values. So this looks a little bit like this section in the study guide here, where we had some x values, we had an equation, and then we substituted the x value into the equation to generate the y value. In this example, it was a linear equation. So this might seem a little strange, but use the equation to generate y values for several x values and then list them as a point. So pick any number you want for x, substitute that number into the equation, and then you get a y value. So what does that look like here again? Pick any number you want for x, substitute it into the original function, the original equation, and then you generate a value for y. Then you can graph those ordered pairs and you get what you're looking for. You get your line. Okay, so I hope that made sense for you there, looking for that. Plot at least 3 points on the graph to see what they make. Well, are they going to make a straight line? If it's linear, then it's going to be a straight line. If the graph is not a line, the function is what? Nonlinear. Okay, definitions here. Coefficient. So a number times a variable. We worked on the study guide with y equals 2x plus 3. 2 is the coefficient. It's the number in front of the variable. A linear function is a function with a straight line. Or a graph. A nonlinear function is a function with a curved line for a graph. Slope is y value over x value. Also known as m. Also known as rise over run, or steepness. Slope-intercept form, y equals mx plus b. M is slope, b is the y-intercept. Supposed to have a dash in there, I always forget that. The y-intercept is the place on the line where the graph crosses the y-axis. So where the graph crosses. So when x equals 0, you have your y-intercept. So a quick reminder, that is not anywhere close to a good y-axis. That's a bit better. The graph we worked on looked something like this. The y-intercept is this point right here. X equals 0, so you're going 5, 4, 3, 2, 1, 0. And it's the point where the graph crosses the y-axis. Okay, so I hope the study guide made sense for you. Please, after you watch the video, work on the checkup for this section in Apex. So please do 3.2 checkup. All right, so hope you're well. Please contact me if you have any questions.